Okay, so we are at now the third question here. At a community fair, Alfred observed a game which involved a player selecting, without replacement, 5 balls out of a bag of 6 balls numbered 1 to 6. So let's get a grip of the scenario here. So we have some balls numbered 1 to 6. So it's 6 balls, and each ball has a number, and the numbers are 1 to 6, right? All right, so a 5-digit number was then formed by placing the selected balls in the order in which they were drawn. For example, the number 21463 suggested that the ball labeled 2 was drawn first, the ball labeled 1 was drawn second, and so on. A player wins a prize if the 5-digit number is greater than 50,000. Alfred set out to find the experimental probability of winning the game. He made a sample observation of 30 persons as they played the game, and the outcome totaled 9 wins. Describe the most suitable sampling method for Alfred to use. And of course, the most suitable method he would use here is randomly. So he's randomly select players. All right, so randomly select players. All right. If 30 persons represent a sample, explain what the population would be in this context. The population would be every person at the fair who play the game. Alright, so that's the population there. Everyone at the community fair that played the game, and of course he selected a random sample of 30 of them. The outcome of each game is called a variable. Classify this variable as either qualitative or quantitative. So the outcome, I guess you could put the outcome to the outcome would be win or lose. So the possible outcome would be win or lose, and of course as category. So this would be qualitative. So the outcome would be in categories, all right? You either win or you either lose. You either get above 50,000 or below 50,000. So that's categorical. Evaluate which of the values of location is suitable in summarizing the possible outcomes. And then this would definitely be the mode. All right, mode. Since the outcome is categorical, or I could say qualitative. Alfred wishes to determine the theoretical probability of winning a game. Calculate the number of unique 5-digit numbers that can be generated. All right. So remember remember it was 6 numbers labeled 6 balls. So 6 balls. Each of them has a number, and the numbers were 1 to 6. All right. So 5-digit numbers. Let's say that's 1, 2, 3, 4, 5. If we're the number of 5-digit numbers, the permutations here. In the first slot, notice you have 6 possibilities. In the second slot, after you place a first number here, they would have 5 in the end. Next 4 the fourth number, you only have 2 numbers remaining. Select some, all right? So the number, so that's we can do it like that, or we can use the formula NPR. So 6 pick 5 using a calculator. This should give you 720. Or if you multiply 6 times 5 times 4 times 3 times 2, you end up with 720. Alright, so there are 720. The number of unique 5-digit numbers will be 720. Determine the number of unique 5-digit numbers greater than 50,000 that can be generated. So again, so if you have the number has 5 digits, let me put the slots here, 1, 2, 3, 4, 5. Now, if the number is greater than, for the number to be greater than 50,000, then you'd have to begin with 5 or 6. You'd have to begin with 5 or 6. So the number would have to either begin with either 5 or 6. So in the first slot, there are 2 possible numbers that can go there. And after you put either 5 or 6 there, then you'll be left with the second slot. You have an option of any 5 numbers. The third slot, any 4 numbers. The fourth slot, any 3 numbers. And the last slot, any 2 numbers. So it'll be 2 times 5 times 4 times 3 times 2. So that would give us what now? That would give us 240. So 240 5-digit numbers can be selected from these, which would be greater than 50,000. Calculate the probability that a player wins a prize. So the probability that a player wins a prize would be, of course, how many numbers can be bigger than 50,000? 240, and then now remember it was 720 possible unique 5-digit numbers. So 240 over 720, I think that's 1/3. Part C. Alfred decided to play the game on the condition that if he lost on his first try, he would play exactly 1 more time. But if he won on the first try, he would stop playing. Draw a probability tree diagram to reflect the possible outcomes for Alfred. Let's do a tree diagram. So, let's do a tree diagram. So, Alfred. Now, start from here. Now, the possible outcomes, Alfred can win, or he can lose. Alright? The probability of winning is 1/3. We just found out to be 1/3, 240 over 720. And the probability of losing, which would have to be 2/3. Alright? Now the question says, let's see what it says again. So, if he loses on the first try, he will play 1 more time. So if he loses, he's going to play again. So he loses, he's going to play again. And if he play again, he can either win the game, or he can lose the game. The probability of winning doesn't change, it's 1/3. And the probability of losing is also 1/3. And the question says, if he win on the first try, he will stop playing. So if he win, him stop. Alright? Let's write this out now. So let's multiply along the branches here now. So 2/3 times 1/3, that's 2/9. And 2/3 times 1/3. Loses 2/3, sorry. So 2/3 times 2/3, that's 4/9. So if him win, there's a 100% chance him stop. Alright? So 1/3 times 1, that's 1/3. And by the way, if we add all of these probabilities going down, we should end up with 1. 1/3 and 2/9 and 4/9 should give us 1. Calculate the probability that Alfred wins the game. So the probability that Alfred wins would be this 1/3 and 2/9. So the 1/3 and 2/9. Now if add these, what's 1/3? 1/3 is 3/9. So 3/9 and 2/9, that's 5/9. That's 5/9. All right. Question 4. The marks X obtained by students of social studies in a grade 9 exam are normally distributed with mean 60 and standard deviation 8.5. Two friends, Amy and Sharon, obtained 69 and 82 marks respectively. Write the distribution of the marks in the form. Right, in that form there, X and the normal distribution, the mean, mu, which they were told that the mean is 60 and the sigma standard deviation there is 8.5, so 8.5 square, and 8.5 square would be the variance. Calculate a z-score corresponding to 82 marks which Sharon obtained. So z, the formula for z is x minus mu over sigma. Sigma stands, so mu is means, and sigma standard deviation. So 82 marks, so x 82 minus, we are told the mean is 60, divided by 8.5. Sigma, we end up with what now? To 2 decimal places, we end up with z equal to 2.59. The z-score for Amy 69 marks was found to be 1.059. What is the probability that a randomly selected student scored more than Amy? Alright? So Amy z-score was 1.09. Alright, so the probability that a student score more than Amy, which is more than 69, is the probability that the z-score is 1.06. Z is greater than 1.06. So we can use the table for that. We can use the table. Alright, so we can get the probability for which z is greater than 1.06 using the table. Let me just go to a table and Google here. So here's a z table I get from Google here. Values represent area to the left of the z-score. So the values here are given for the less than. So we're looking for z is 1.06. So the furthest left, so we're looking for 1.06. Alright, so here is it. So 1.0. This is 1.0. So 1.06 would be here. 1.06 is 0.85543. But these values are for the less than. These values in the table are for the less than. So it's for the greater than, it will be 1 minus. So the solution will be 1 minus 0.85543. So 1 minus 0.855, and I will end up with 0.145 if I'm using 3 decimal places. Part B, it is given that 20% of the 180 students in a certain school failed the social studies exam, and the number of students Y who failed follow a binomial distribution. Why is it reasonable to assume that the number of students who fail the examination follows a binomial distribution? So we can remember the characteristic of the binomial distribution. So there are usually about 5 characteristics, but 2 marks, I guess we could list 2. Notice we have 2 possible outcomes. So one of the reasons we have 2 possible outcomes, pass or fail. Also, the finite number of trials. In this case, the students who sit the exam will be the trials. So finite number of trials, or finite number of students in this case, and each trial is independent to the next. All right, so the trials are independent. Determine the expected value of y. So for the binomial, the expected value of y, or whatever the variable is np. N is the number of students, 180 students, and the probability is 0.2. Probability of failure is 0.2. So 180, I'll talk about probability of failure here. 180 times 0.2, that's 36. Calculate the probability that at most 1 student failed the socials to the exam in a class of 9 students at the school. So n is 9, number of trials is 9, and the probability at most 1 student fail. So at most 1, so we want the probability, what we want is the probability that y is less than or equal to 1. The probability at most 1, so y could be 1 or less. Alright, so that means y could be 0 or y could be 1. Let's work out the probability. The probability for when y is 0 and when y is 1 now. Remember the binomial formula, nck p to the k and 1 minus p to the power of n minus k. In the case here, in the first one here, n is 9 and p was what, 0.2, so p is 0.2. Alright, so for the first one, in which we're using n 9, so it's 9 choose 0. This one case here, so it's 9 choose 0. And p is 0.2, so 0.2 to the power of 0, and in the bracket 1 minus p, so it's 1 minus 0.2, that's 0.8 to the power of 9 minus 0, which is 9, plus probability y equal to 1 now, so now it's 9, so it's 9, so it's 9 choose 1 now, so 9 choose 1, and the probability p 0.2 to the power of 1, and in the second bracket 1 minus p, which is 1 minus 0.2, that's 0.8 to the power of 9 minus 1, and 9 minus 1 is 8. Alright, so we end up with 9 choose 0. No, 9 choose 0 is 1. So this is 1, if you can use a calculator for that. 0.2 to the power of 0 is also 1. So this is really 0.8 to the power of 9 plus, and then over here, 9 choose 1. We can use our calculator for that. 9 choose 1 times 0.2 to the power of 1 times 0.8 to the power of 8. So we can use our calculator for that. Just use a calculator here and I write that out in one instant. So all of this will work out to be 0.302, and then 0.8 to the power 9. 0.8 to the power 9 was 0.13, so it's 0.134 plus 0.302, and this gives us 0.4 36. Mr. Springer, a teacher at the school, believed that social studies grades depend on English A grades. The marks which are out of 100 obtained in social studies and the corresponding English grades for each student who did both courses are detailed in the table and plotted on the scatter diagram below. The mark of one student in social studies is misplaced and is therefore marked here. Okay, it's talking about this mark. So let's explain the table. So this table, for each student, 2 scores are placed here for the social studies marks and the English A marks. So this student got 51 for social studies and got 45. The same student got 45 for English A. And it goes down, and again for the final column here, this student at the end got 91 for social studies. The same student got 87 for English A, and that's how the table is. And the scatter plot, notice we have a scatter plot diagram here. All right, so on the x-axis we have on the horizontal axis we have English A, and on the vertical axis we have social studies. So for example, this student, the first student, 51 for social studies, 45 for English. So they plot 45 and 51. So 45, which is about the midpoint here, and 51. So they correspond. So a graph is done. Well, points are plotted for these values. All right, each pair of values there. So English on the x-axis, social studies on the y-axis, and we have a plot there. So we are asked to find the value of k, given that the mean mark for social studies was found to be 60. So for social studies, if we find the mean of all of those values, we should get 60. So for social studies, how many numbers we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we can pause if we then add up all of these values and divide by 17, and the mean should be 60. So if we add up all of these values, let's use a calculator, add them up, pause if we don't add them up. When I add up all of these values, we'll get 920 plus the k. So remember the formula for mean. The mean is equal to 60 for social studies. So when I add up all of these values, and how we get the mean, remember the formula for mean is sum of all the values over n. That should give you 60. And n is the number of values. Remember, we get 17 values. So 17 values. And we'll add up all of these 17 values. We'll add up 16 of these values. We get 920 plus the k. We don't know what k is. That's what we're trying to find. So we end up with 920 plus k. And of course, now to solve for k, we can multiply both sides by the denominator, multiply both sides by 17. So we end up with 920 plus k, like that, and then 60 times 17, what's that? That's 1020. And we can subtract 920 from both sides. So k is 100. By making reference to the features of the scatter diagram on page 16, describe the correlation between the marks obtained in social studies and English A. So let's look at the graph again. If you look at this correlation, I would say the correlation, it's a linear correlation. Since you can draw almost form a straight line, it's positive, and I would say it's a strong correlation since the points are reasonably close together. So I would describe the correlation here as I would say it's linear. I would say it's a positive correlation, meaning the scores move in the same direction. So if a student has a good mark for English A, they're going to get to have a good mark for social studies. All right, and I would say it's a strong correlation. 3 marks, so I would say label these 3 characteristics to describe the correlation. On the scatter diagram on page 16, draw a straight line of best fit that may serve as the linear regression line for the plotted data point. So the best fit line, and of course you use a ruler, is a line, straight line. So you use a ruler, let's try to use a ruler and draw a line. Draw a line as balanced as possible, a line that should run through all of these, maybe in the center of these points here. Let's draw a straight line through. And of course you use a ruler, connect it and cut. And any line looking like that are reasonable. You will get the marks there.